My name is David.
My name is Linda.
My name is Alex.
My name is Jimmy.
And this is our Robotic Hand.
Why did we choose this challenge?
We chose this challenge as we wanted to build a device that would help disabled individuals with everyday life tasks. From our design manifesto, it was clear that our group was dedicated and eager to build a device that was going to be one of a kind. However, as we progressed through the design process, we quickly changed our ideas. Originally, we wanted to replicate the physical appeal and physical strength of a human hand. However, as we encountered more and more barriers, our design ideas began to change quickly.
What were the requirements and constraints for this project?
Okay, so when we first read the design challenge, we are required to do the 4-finger and thumb manipulations, and we are required to do the wrist rotations with a constraint of 180 degrees. We were given like 3 sensors and 6 motors to build a whole robotic hand.
Can you give me a brief description of the product?
The main component of our device has a palm with 4 fingers and a thumb and 3 motors at the back. And also we have 1 sensor in the middle of the palm. And then the wrist is connected to the base. And also we have 2 NXT bricks and it stores 6 programmings. Now Alex and David will give an in-depth description.
The hardest part of group sync by far for the project is the whole hand, which consists the palm and the fingers. We originally designed the fingers with 3 joints, but we thought this way would be way more easier. So we basically 3D print the fingers with the ABS materials. Then we decided to 3D print the palm as well, but it didn't work out so well. So we laser cut a palm and glue them together. But this is pretty heavy though, so we drill holes to reduce the weight of the palm.
The fingers were attached to the palm using metal rods, same for the thumb. And elastic bands were run behind the fingers and the thumb, so attached to a stable part of the motor, and fishing line was run from the front of the finger through holes here to the motor here. And when the motors rotate, the fingers and the thumb close. The motors were mounted on the back of the palm to prevent tangling from happening. And we had additional holes for lightweighting, as David has mentioned, and for the sensors. Linda will now give a detailed description of the base.
Alright, so for our wrist, originally we had a differential system consisting of those 3 gears. And we use this system because it only uses 2 motors and it allows both rotation and tilting of the wrist. But after our palm didn't get 3D printed and we used our acrylic palm, it was way too heavy for the differential system to hold up and pull so it doesn't allow rotation and tilting. And then we switched to this system where there's 3 motors, and the top motor will be rotating from this part, and as you can see, it attaches. And the bottom 2 gears will just allow tilting of the hand. Our base is on wheels because originally we had an extra motor left over and we wanted to make the car move. But then now we use 3 motors for the wrist. We just kind of kept the cart on wheels for appearance-wise. And the NXT bricks are attached to the back just so there's a little bit of weight on the back, and when the hand attached to the wrist, it's not going to fall over. And now Jimmy will give a detailed description of all the programs we have written for this.
Programs that were stored in the NXT brick controls the hand and the wrist mechanism. So all the motors can be manually controlled by the NXT buttons on the brick. For the hand part, it has 2 grasping positions. One is the power grip, which is 4 fingers moving, and one is pinching, which is 2 fingers and a thumb moving together. And for the touch sensor, so when the touch sensor is activated, 4 fingers will be closing, and after 5 seconds, they will automatically open again. And for the color sensor, it can detect different colors, and for different colors, it can do the power grip or the pinching. The wrist mechanism, it has 2 motions. One is wrist rotation and the other is tilting. So for the wrist rotation, by programming, it is limited to 180 degrees.
How do we implement our test plan?
So many of the constraints and specifications of our device were tested through observation, such as the NXT bricks, the inclusion of 6 motors, and the sensors. However, other functionalities such as the forefinger and thumb manipulation and wrist rotation were evaluated through demonstration. So we even use a protractor to measure the constraint of 180 degrees of wrist movement, and we did another test to see the maximum weight our device could lift.
The test conducted by our group is pretty successful, and the proudest thing of our group is the fingers. The ability of picking up heavy stuff really make it stand out from all the other robotic hands. Although it's not part of the constraint, but our personal failure of the whole design is the wrist, because it cannot tilting pretty well because of the palm is
How
too
did we
heavy.
get along as a group, and how did this affect our overall design process?
Well, oftentimes we didn't get along as well because we all had different ideas and we all thought that our ideas was better than others. But at the end, we communicated and we discussed on everyone's ideas and picked the one that is more suitable for our design and that will be more presentable in the end. And from this, we learned that communication is really important during teamwork, and we can apply this skill in future projects so it will be more efficient.
What was the most important thing we learned from this experience?
So the most important thing that we've learned from this project is nothing goes according to plan during engineering process. For example, we try to 3D print our palm, but laser cut is our only option. And for the wrist mechanism, we try to use differential system, but the hand is too heavy, so we have to go with this design. And for the base part, we want to make it move, but we don't have enough motors, so that's the only way. And essentially, we need to keep on trying, and that's the way of design.
In conclusion, our project did not turn out as well as we expected, but we're still really proud of it and we learned a lot during the design process. We thank Andy, all the TAs, and all the fourth year students for helping us throughout the design process, and we're really grateful that you were here for us and you provided the opportunity for us to do this amazing project.
Thank you.
Thank you.